So when you're talking about trigonometric functions, what I mean by a trigonometric function is sine, cos, and tan. Okay. What you have is I'm using a circle to represent angles from 0 to 360 degrees. Okay, so that's 0 to 360 degrees. So that's 0 here. We're going anti-clockwise. Okay, and that's 270, and that's 360. Okay. Now, when you guys, if I go to my calculator, if I enter in sine any number between 0 and 90, all right, you're guaranteed a positive answer. Make sure it says D on the top, so go to Shift, Setup, make sure your angle and units are in degrees, otherwise the whole thing messes up badly, okay? So, if I enter anything like, if I enter sine 56, my answer will be positive. If I enter tan 60, my answer will be positive. If I enter in cos, anything between 0 and 90, it can be cos 1 degree, my answer will be positive. Everybody cool with that? You can check that yourself if you want. Cos, sine, and tan, any angle you can take up between 0 and 90 will result in a positive number. So we call this positive for everything, or A positive means all. Everything is positive. Okay? Next thing, we're now experimenting between 90 and 180. Once again, you press sine 100, you go for tan, let's say 100 as well, and cos 100. Oddly enough, the pattern's a bit different this time. Does anyone know what happens? Yes? Sine positive and the other two are negative. So what we call is sine positive. Okay? Nextly, we go in between 80 and 270. So we'll pick any number we want, let's say 220. And we once again try out the calculator on all three numbers. And when we try out the calculator on all three numbers, we'll find out that. Which one's positive this time? It'll be tan. Tan is positive. Alright, and finally, process of elimination. What do you think the last one's going to be? Cos. Right, if you need to learn this off by heart, Anto stole the car. ASTC. Alright? Or whatever way you want to do it. Yeah, that's the way I did it. So you have a choice on what you want to do. Now, there's certain rules you need to learn for each section, okay? So, what is referred to is all is the first quadrant. So there's 4 quarters of the circle. All is the first quarter, S is the second quarter, T is the third quarter, and C is the fourth quarter. Everybody go with that? Now, also we have to do is focus on S. We won't be asked for anything else for the time being. And by the time I need to do it again, you're going to already have this covered in class, okay? So I'm just going to focus on exactly what I need here. So, essentially, when you're in between 0 and 360, how many places will sine be equal to a half, do you reckon? It'll be positive twice, won't it? And its range of values of sine is from 0 to 1. So in the first quarter, sine experiences all the values from 0 to 1. But also experiences all the values of 0 to 1 in the second quarter as well. Okay? So how do we find this? Well, there's 2 rules, right? So the rule for the second quadrant is 180 minus r. I'll explain what I mean by that now in a second. The rule for the third quadrant, if you really want it, is 180 plus r. The rule for the fourth quadrant is 360 take away r. Now, let me explain what r is. If I give you a question like this, let's say sine A equals, I don't know, minus root 3 over 2. Everybody see that? Ignore the root 3 over, ignore the minus part, and just sine inverse root 3 over 2. And what do you get? Sine inverse root 3 over 2. 60, isn't it? Now, 60 is your r value, which means what two places is sine 6? What two angles is sine equal to root 3 over 2? The first answer is 60 degrees. Oh, sorry, no, the first answer is not 60 degrees. Excuse me. Sine is negative, isn't it? Which two quadrants? Oh dear. Anywhere? Oh, thank you. Alright. Should have told me. Which two quadrants is sine negative in? Pick them out for me. Which ones are they negative in? Third and fourth. What's the rule for the third and fourth that I have on the board? Yeah. So do 180 plus 60, and then 300 take away 60. And what are your two answers? The answers are 240. What happened there? Right. The answers are 240 and 300. Would there be any way of checking your? Would there be any way of checking your answer? Give me a minute. That's great. Continue. Sorry about that. Fun times. Now, what we agreed on earlier was when we sine inverse root 3 over 2, we ignored the minus. We got 60. We then ran it through We ran it through quadrant 3 and quadrant 4 because that's where it's negative. We got an answer of 240 and 300. You could check your answer by putting in sine 240 into your calculator, and it'll tell you that it's minus root 3 over 2. You're confirming your answers. Then you put sine 300 into your calculator, and you also get the same answer. You know you're correct. Now, the next question we decided to do was sine A equals a half. Now, a half in this case is perfect because which two quadrants is the answer located in? A half is positive. Where is sine positive? Quadrants 1 and quadrant 2. So that's perfect. So all what we need to do is sine inverse a half. And what happens when you sine inverse a half? You find out it's 30. So what are your two answers then? 180 minus 30 is 150. So two answers are 30 and 150. Is that okay with you guys? Nextly, I'll throw you a bit of a curveball. So 30 and 150 are the answers for this question. No worries. Nextly, I'll throw you a bit of a curveball. And the curveball I threw you was it cos A, was it? What to say cos A equals? Minus root 3 over 2. Once again, I asked that you ignore the minus parts. And you just cos inverse root 3 over 2 and you get 30 degrees. What two quadrants is cos negative in? It's negative in 2 and 3. Use the rule for 2 and the rule for 3. So what will be my two answers? 150 and 210. And if you check out your answer, cos 150 minus root 3 over 2. You know you're correct. Right? That's basically how you master the angles of a full circle. Okay? It's very easy. Learn your rules off by heart. Learn that diagram off by heart. And you're good to go. Alright. Let's get to the actual question now. So, a particle is fired from a point on a horizontal plane with initial speed 28 and angle A to the plane, or angle alpha. So, there's angle alpha. And this here is, what's the 28, is it? Alright, so what does that make this one? 28 cos alpha, and this one? 28 sine alpha. Let's run through our formula here. Phi x and phi y. So what's phi x, lads? Phi x, 28 cos alpha, yeah. Phi y, 28 sine alpha, but there's something else. Plus at, which would be minus gt. Alright, sine x, velocity multiplied by time. So multiply your vx by t, and what you get? 28t cos alpha. Alright, the one after that then, sy, 28t sine alpha, and then what you do with the gt? Half it and add on another t squared, right? Brilliant. It tells me what the range is. So what can I put this equal to? Sx or sy? Yeah. Sx equals 40 and 28t cos alpha equals 40. The time of flight t is the same as 40 over 28 cos alpha. In your test, always make sure you break it down to the smallest fraction possible. 10 over 7. So 10 over 7 cos alpha. Alright. What are we going to do next? Tell me. What do we also know about the range? What's guaranteed about the range when you lob it in? Would you not argue that Sy is guaranteed to be 0 at the time of flight? So what happens when I sub in t? What happens when I grab the Sy formula and sub in t? What should happen? It should equal 0, or has to equal 0. 28 times whatever t is, times sine alpha, minus a half, g, the time squared, yeah? I'm pretty lazy, so I'm going to square the time right away. So what happens when I square the time? What do I get? 10 by 10 being 100 on top. 7 cos alpha multiplied by another 7 cos alpha. 49 cos squared alpha. For those of you that don't know, cos squared alpha means cos alpha to be squared. They are the same thing. Okay. Now, this is also 40 over 28 cos alpha. Now, if we remember all our training, what can we say first? What's sine alpha divided by cos alpha? Tan alpha. The 28's cancel. And I'm left with 40 tan alpha. If you read the description of the question, it says you're going to find 2 angles of projection. What type of formula does that link you think you're going to end up with? It's got to be a quadratic, alright? Does it currently look like it looks like a quadratic with this part, but the 2 variables are separate. Now, here's a rule you're going to need to know off by heart, alright? So I'm going to introduce 2 trigonometric rules. They're in your tables, but you're going to use them a lot. The first rule is this. Sine squared alpha plus cos squared alpha equals 1. No matter what angle you pick, if you were to pick sine squared 4235 plus cos squared 4235, guess what the answer is? It's 1. Alright? No matter what. Now, next trick I'm going to pull off is I'm going to divide both sides by cos squared alpha. Alright? And you'll see what will happen in a second. So, what happens here? What's sine squared alpha divided by cos squared alpha? Tan squared alpha. Okay. What's cos squared alpha divided by cos squared alpha? 1. And then finally, this is 1 over cos squared alpha. Exactly what we're looking for, isn't it? You're going to do this substitution a lot. Okay? In your tables, it's written as 1 over cos squared alpha is written as sec squared alpha. They mean the same thing. Okay? They just use the different. To avoid using fractions all the time in code, they created a new function that's the same as 1 divided by cos. Once again, for your point of view, all you guys need to know for this chapter is just learn this off by heart. This one here. Okay? Because you're going to use it a lot. Alright? So, can anybody suggest my next course of action with this part here? What can I do with that? Yeah. Do you know what else I'm also going to do? Do you see the G there? Wouldn't that be handy if I turned that into 9.8? And then half of it would be 4.9. And then it could interact with the 49 on the bottom. I think that would be a really useful call. So a half gravity is 4.9. Next, we're going to have 490 divided by 49, which would be 10. I still have my 1 over cos squared alpha there, don't I? So what's 1 over cos squared alpha? What can I swap that out for? Yeah, tan squared plus 1. How many variables am I down to now? What? 1. Exactly. Now down to 1 value, which is great. And that should equal 0. Now, let's multiply this out. And we should get minus 10 tan squared alpha minus 10 plus 40 tan squared alpha equals 0. I'm going to have to divide both sides by minus 10. So I'm going to get tan squared alpha minus 4 alpha plus 1. Oh, sorry, not 4 alpha, 4 tan alpha. Plus 1 was this. Somebody double check that for me.
Is minus 10 about tan squared tan alpha?
Ah, that is a very valid point. I multiplied that one by that one.
No, tan alpha.
Oh, it's up here. The sine alpha and the cos alpha became tan alpha. And tan alpha multiplied by 40 becomes 40 tan alpha. Oh, I see. But did I not divide across by 10?
You have 40 tan alpha and then
Oh, sorry. It's squared for some reason. Thank you. Thanks very much. 40 tan alpha, not. And this line was correct, but I made a little error there. Okay, thank you. Now, minus b formula. Will somebody do that really quickly for me? A equals 1, b equals minus 4, minus b equals plus 4, c equals 1. Really quickly, guys, somebody do it. You all know how to do a minus b formula, don't you? Right. Get me both answers in fraction form, please, okay? Or surd form, whatever comes first. 2 plus root 3, and the other one's 2 minus root 3. Will you call inverse both of them then, and get an angle for me?
mean
15 degrees. Yeah, and the other one? Yeah, that makes sense, because do you know when you throw an object, or if you do the perfect throw, two things can happen. Or sorry, when you don't do the perfect throw, two things can happen. If you go too shallow, it goes up and then goes back down again. And we've all discussed that 45 degrees is the largest throw. So red would be around 15 degrees. Blue would be 45 degrees and will take you longer. And then the opposite extreme is true. What happens if you throw it up at 75 degrees? So those two answers make legitimate sense, that you have the same range for those two types of throw. A short angled throw versus a high deep throw. They cover the same distance. If you throw it somewhere in between around 45 degrees, you go much further. Alright? So if you ever get answers like that, you know you're on the correct path. Right? You immediately get a feel good feeling and go, okay, I'm pretty sure I nailed that. Now, alright, off you go. You start this one ahead of me. Yeah. Particle is fired from a point on horizontal plane with initial speed 10. Greatest height reached above the plane is 2.5. Find the sine of the angle of projection. Okay. So, fire it. Greatest height is here. Come back down again. And you're at 2.5. That's your phi y equals 0, because you can't go anywhere. And, alright, then you have your angle. So you should have 10 cos alpha and 10 sine alpha. Sine alpha. Then you got to make your 4 equations. 10 cos alpha, phi y equals 10t sine alpha. Then Sx equals 10t cos alpha. Made a mistake there. There's no t. Second one. I also forgot the gt. Okay. Sy equals 10t sine alpha half gt squared. Now, place phi equals to 0 for the greatest height. And then you're going to get 10 sine alpha minus gt equals 0. Then you're going to get gt equals 10 sine alpha. And time equals 10 sine alpha over g. Max, what's the next step? So, yeah, which equation? It's a vertical height. We're told this is 2.5. So which equation? Yeah, Sy is vertical height. So you replace the Sy with 2.5. Sy is replaced with 2.5, and then you're going to go 10 blank sine alpha minus a half to g blank squared. Alright, so it's 10 sine alpha over g. The next one's t squared, so I'm just going to square that out into 100 sine squared alpha over g squared. Now we're going to have a good look at this. Now, we're going to get 2.5 equals 100 sine squared alpha over g. The g here cancels with the g there. So we're going to get minus 100 sine squared alpha over 2g. We're going to do the smart move here. Change that to 200 over 2g. And then we're going to get 2.5 equals 100 sine squared alpha over 2g. Isolate sine squared alpha on its own, and we'll get 5g on top, because 2 times 2.5 is 5g over 100. Put in g equals 9.8. So what's great about that is it comes out as 49 over 100. Now, does it say angle or angles? Huh? Just one, isn't it? Would an obtuse angle make sense in this case? What happened if you fired it off at an obtuse angle? Make no sense, would it? Because you're essentially firing it backwards, aren't you? So that makes no sense. So just the one angle that matters. So we're just going to do sine alpha equals 7 over 10. Inverse that, what do you get? Or are we done? Oh, we're done. 7 over 10. Have we killed that? Alright. Move on. Alright, 19 please. PI and QI, no bother. But to me, I've been using U and cos and sine alpha a lot recently. Worked out quite well. So go alpha. I'm going to call that u. I'm going to call this u cos alpha, and this u sin alpha. So essentially, whatever answer I get for u cos alpha is t. Whatever answer I get for u sin alpha is q. Alright, that's the first thing you're going to settle on. Now you're going to do what you always do. You're going to make your four equations. Okay, so you're going to get bx equals u cos alpha, by equals u sin alpha, sx equals ut cos alpha, minus gt, sy equals ut sin alpha, half gt squared. Alrighty. You know the range is 60, don't you? Yeah? So, range equals 60. And range is an Sx function. So, we're going to put ut cos alpha equals to 60. And then we're going to get t equals 60 over u cos alpha. Alrighty. Out of interest, a little cheat here. I'm thinking of doing a little shortcut. Could anybody suggest how could I use the time of flight to relate that to the greatest height? What's the trick? You can half it, couldn't you? Why you don't half it? Is it symmetrical? Is it on horizontal ground? It is. So I'd say if the time of flight is 60 over u cos alpha, then the time to the t1, which is the time to the greatest height, or we call it th, might be 30 over u cos alpha. Because it takes half the time, same time to go up and same time to come back down again. Now, if I throw that into the sy equation for t, I'm sure the answer has to be 5.625. So let's work on that, see if it works out first. So, u times 30 over u cos alpha sin alpha minus, we'll do a half g is 4.9. I have a feeling we'll need it. And t squared is this thing squared, so it's going to be 900 over u squared. Oh, that's interesting. Oh, yeah. U squared. Value P and value Q. Alright. Does anybody see any potential problems in our near future? Have a look at where I'm at. I'm currently rethinking a new way of doing this question. Can anybody tell me why I'm rethinking a new way of doing this question? Go a step or two in the future without actually doing it. Where are you going to end up? I don't think I'm getting rid of that u squared, am I? On the right hand side? Nope. Not getting rid of that u squared. The u's on your side cancel. So to me that's two variables for one equation. I'm not happy with it, so I'm going to have to look at it and think of something else, okay? So give me a second. It was a good idea to try and plug it, half it, go directly in. It's a smart idea, but we've caught a problem early. The problem is you're going to have a u squared on the bottom that you can't do anything about. Everybody cool with that? When something like that happens to you, and it will happen to you, you call it quits. You go, okay, I'm not going down that rabbit hole. That's a bad way to go. The math should be easier than that. Okay? So what did I forget? I forgot something really clinical about the range. What else happens at the range? At the range, sy is guaranteed to be 0. That's the way I should have went. So we go again. U t sine alpha minus a half. So you can see even a very thought out like logical methods can lead you down a rabbit hole. Okay. It's 0 this time because it's sy equals 0. Now it's going to be 60 over u cos alpha. Oddly enough, we're going to encounter exactly the same issue, aren't we? Do you agree with that? We're going to encounter the same issue again. But if I encounter the same issue twice, maybe I could use them against each other. So maybe I should have used the old equation as well, and then used them against each other somehow. We'll figure it out, don't worry. Alright, difficult question to be fair to it. So in this case it's 3,600, what is it? U squared, cos squared, alpha. I think what I'm going to do is I think I'm going to isolate u squared cos squared alpha in this equation, and then I'm going to substitute it in for the other equation I had a minute ago, and that will hopefully eliminate the u squared from existence. That's my plan. Okay, it should work. It's messy, but it should work. Does anybody have a better way of doing it? Alright, let's go and get messy. Now, the u's cancel. Sine alpha over cos alpha is tan alpha. This is an absolute, this is awful. So that's already been squared out, hasn't it? So this is going to be minus 1,800g. What's the part I'm not happy with? I'm not happy with the u squared part more than anything. But in for a penny, in for a pound, I'm going to take out the whole thing. This whole thing is going to just have to come out. Okay? So it would be equal to 0, wouldn't they? When I bring it over the other side, it's the same thing as me just changing that minus to an equal sign, isn't it? Did everybody follow that? When I bring that to the right, it's the same thing as me changing that to an equal sign. So I'm just going to be a bit lazy here because I know I'm in for a war. And what we're going to get next is I'm going to isolate the u squared cos squared alpha. And I'm going to turn that into 180 g over 60 tan alpha. I'm sure there's something I'm not seeing this morning, but look, this sometimes happens to you. Applied maths part again. Now, oddly enough, I'm going to go back to where I was. Remember I thought I made a mistake earlier? Remember that piece of information I gave up on? Actually, it's going to come in useful now. So, I'm going to go back to that trick I talked about a few minutes ago. I'm going to half the 60, I'm going to turn it into 30 over u cos alpha. And what did we expect to happen to the sy when we have a t of 30 over cos alpha over u cos alpha? That's the time it takes to reach its greatest height. Everybody cool with that? So the sy should be equal to, what's it, 5 points? Yeah, so I'm going to have to do exactly the same thing. It's messy. Sine alpha minus a half g. What's this when I square it out? 900 over u squared cos squared alpha equals, oh god, what am I doing now? 5.625. Alright, I think I'm going to get there, lads. I think I'm happy. I think I'm optimistic. Alright, so the u's cancel. Sine alpha over cos alpha, 30 tan alpha. We're running into this problem again where there's a u squared, unwelcome u squared cos squared alpha, which I can't do anything about. So what I'm going to do here is going to half the 900. So I'm going to go 450 g all over u squared cos squared alpha. Now, what am I going to sub in there instead? I'm not going to use that anymore. So what am I going to put in here instead? 3g over tan alpha. And if you have a fraction on the bottom, what's that the same as? What's 1 over 30g divided by tan alpha? What's that the same as? Tan alpha over 30g. Look what happens now, lads. Now you're smiling. G's cancel. 450 divided by 30. 15. 30 tan alpha minus 15 tan alpha. No bother, that is 15 tan alpha equals 5.625. Divide your 5.625 by 15, and what you get? 3 over 8. That seems nice. Tan alpha equals 3 over 8. Does it want me to find the angle? Oh dear, yeah, we're definitely going to need the angle, aren't we? Will we find the angle in the third form? It's more accurate. So, yeah, we're in a war. Alright, that's 8. Sorry, opposite is 3. Adjacent is 8. So what can we say now? That's 3 and that's 8. We need to find the hypotenuse. 64 plus 9. Square root of 73, don't we? So I now know what sine alpha is. 3 over root 73. Cos alpha is 8 over root 73. Now, what's the problem? If I go back to the start, I need u as well, don't I? So, this is fun. I now have got to figure out how I'm going to find out u. Right? Should be reasonably okay. Yeah, I can calculate it. Pretty sure I can calculate it here. Get rid of that. Give me a second. I did have u squared cos squared alpha equals 30g over tan alpha, didn't I? I had that, didn't I? So, why don't I just do u squared equals 30g divided by tan alpha cos squared alpha. And I have all those inputs, don't I? They're all there ready to go. So, it's going to be u squared equals 30 times 9.8. Let me get the calculator for me because I'm going to need it. What was tan alpha again? Tan alpha is 3/8. What was cos alpha? Cos alpha was 8 over root 73. So it's 8 over root 73 squared. Well, I'll answer the calculator and what you get for u squared. Something nice, I hope. Nothing nice now? Ah, lads, come on. Now the funny thing is, we'll probably do this again another day, and there'll probably be a much easier route than the one we just taken. But this is part of applied maths. It isn't perfect all the time. Sometimes you end up going down a route that you shouldn't. What? Oh, root 73. Figured that was a nice number. Ouch. Fair enough. I have to square root that, don't I? Because that's u squared, isn't it? So square root the answer. Ouch. Alright. 29.9 or 7 root 73 over 2, no bother. So u equals 7 root 73 over. You'll be surprised actually now in a second. Because look, we now have to do u sine alpha and u cos alpha. And you'll see what happens in a second. So it's going to be 7 root 73 over 2 multiplied by cos alpha and 7 root 73 over 2 multiplied by sine alpha. And if I remember correctly, the root 73 is on the the bottom. So it's 3 over root 73. And what's the other one? 8 over root 73. Then what happens here? Cancel, cancel. 56 divided by 2. 28. 21 divided by 10. 10.5. Okay? So we want to check if that's the correct answer. It is. Now, although I got that right, there's got to be some mistake in a road I've taken, because that seems very long and very messy, doesn't it? So your job over the weekend, we're not going to move on from this. Your job is to finish off the last 4 questions, 16, 17, 18, 19, 20. And if you can, try and find a quicker, better route to 19 if it exists. You need to go over this stuff again, am I correct? We won't be moving on anytime soon. So you need to go over this stuff again, redo the class, and see what happens next Wednesday.